Alright, for tonight's lesson, our objectives are use properties of congruent triangles, prove triangles congruent by using the definition of congruence. Geometric figures are congruent if they are the same size and shape. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. Two polygons are congruent polygons if and only if the corresponding sides are congruent. There's a biconditional. Thus, triangles that are the same size and shape are congruent. Properties of congruent polygons. You should have your teaching transparencies out. So, we've got two triangles here. And if you know, they're color-coded. So what we have here is triangle ABC and triangle DEF. Okay, so angle A is congruent to angle D. You notice it's the first vertice listed here. So when you're listing congruent polygons, you need to make sure that you have them in the right order, corresponding order. Angle B and angle E are congruent. So it's the second vertice listed. Angle C and F are congruent, so it's the last one. Then if you go over here and look at the corresponding sides, we have AB congruent to DE. We have BC congruent to EF. Must list them in that order. Then we have AC congruent to DF. So let's work with this. To name a polygon, let's say we have polygon P, Q, R, and S. You can name a polygon in consecutive order. So you can say P, Q, R, S. You can say Q, R, S, P. Or you can go the other way. You can say S, R, Q, P. You can say R, Q, P, S. But you cannot go P, R, Q, S. It messes up your congruency statement. When you write a statement such as triangle ABC is congruent to triangle DEF, you are also stating which parts are congruent. So class, it is very important that you have these corresponding vertices and sides lined up correctly. So let's look at this first one. We're going to identify all pairs of corresponding congruent parts. So what we'll have is we'll have angles and we'll have sides. Okay, we don't need the diagram. We can look at the congruency statement. And in my opinion, looking at the congruency statement is easier than looking at the diagram sometimes. Okay, so we have angle P. Angle P is congruent to angle S because they are the first vertice that is listed here. Then we have angle Q. Angle Q is the second vertice listed, so angle T is congruent to angle Q. Angle R, our last vertice, is congruent to angle W. Now let's identify our sides. We have sides. Let me erase this. PQ, congruent. Notice how I went first, second, so I have to go first, second to ST. Whoops. All right, then let's go QR, segment QR, second and last vertice, so it has to be second and last. TW. So what do you think about our last side? Okay? I cannot say on this last one, PR is congruent to WS. This here is wrong. Why is it wrong? Because P corresponds with S, not W. Don't do that. Okay, we're given two triangles here. This is your congruency statement. It's telling you those triangles are congruent. And we need to find the value of X. Value of X. Okay, well, we've got a linear pair here. Angle angle DCB and angle ACB form a linear pair. Well, linear pair, the sum is 180 degrees. Well, if one angle measurement is 90, then you know that this angle measurement is 90. So to solve for x, we can set up 2x minus 16 equal to 90. Solve it like a two-step equation. You're trying to isolate that variable x by using your addition property of equality. And then you're going to isolate that variable x by using your division property of equality. X equals 53. And that's what we're solving for there. Okay, we've got the two triangles that are congruent by your statement. This is the exact same diagram. Now we're going to find an angle measure. We want to find the measure of angle DBC. DBC. We're looking for this angle right here. Okay, well, we've got this measurement as 90 degrees because of the marking. Do we know the measurement of this angle right here? Well, we should. Why? Because angle D is congruent to angle A because of your congruency statement here. And the measurement of angle A is 49.3 degrees. So measurement of angle D is also 49.3 degrees. So we can use our triangle angle sum theorem and say that 90 plus 49.3 plus the measurement of the angle we're trying to find is equal to 180 degrees. The sum of three angles in a triangle equal 180 degrees. Simplify the left side here. Use your subtraction property of equality. So the measurement of angle DBC is going to be 40.7 degrees. All right, this is the end of the first part of this lesson.